Hello friends, welcome to Global Tech Learn. In last video, we learned what are the various types of keys available in databases. In today's video, we will learn what are the different types of joins available in databases that we can use to combine data between multiple tables. If you have not gone through the last video, then I would recommend you to go through that first before continue on this video because keys and join both go in hand, and if you have a good understanding of keys then you can understand joins easily. I have provided the last video link in description window that you can follow to understand the various keys in database. Before we start on joins, I will ask you one question that you can attempt by providing your answer in comment section. I will give heart to the correct answer so you can understand the correct answer for the question. So the question is, what key should be defined for field with below criteria, and the criteria is it should not have the null value and it can have only the unique values, and your options are unique key, primary key, foreign key or identity. Try to give your answer in comment window. Now let's start with joins. In databases we have multiple types of join, that is left join, right join, full join, inner join, and there are two more conceptual joins, that is left anti-join or right anti-join. All these are the joins when we want to join two tables or we want to combine two tables based on some common data within those tables. And also today we will cover union, that is again a type of merging data of two or more than two tables, but it is vertically combining the data. Before understand various joins and or union, let's try to understand the business case where we have some business data that we can discuss and we will try to understand. So here you can see we have some employee data where we have employee ID, that is employee unique identifier to a particular employee, and then we have employee name. The next field we have department, that is in which department employee is working. Then we have what is the designation of the employee, then who is the supervisor of this employee. Then we have salary date on which employee has received his salary. Then what is the month of the salary? Thereafter we have quarter, weekday name, and then the year of the salary date, and the last we have salary amount. Now here in this data you can see we have employee John who has received salary on 31st January 2018. Then John has received salary again on 28th February 2018. That is expected as the employee receives salary every month. Similarly, we can see John has received salary again in March, and same for other employees as well. Like we have Ryan who has received salary in January. In same way, Ryan has received salary in March, and so on. Now this data looks very good when we read it, but when we think of technical perspective where we have to store this data in database, then this data has lot of issues. Now let's see what are the issues in this data. The first we can see the same employee ID or the employee name is repeated multiple times. For example, we have employee ID 1001 John, that is there for row number 2, and then John is again we have at row number 7, then John is again we have at row number 11. So we can see the data is redundant, that means the data is repeated. We have multiple entries for same data point. Similarly, here we can see for 31st January 2018, we have January month, then quarter. Similarly, we have day name, year, and same date is repeated for second employee, that is Ryan, and all the information like salary date, month name, quarter, weekday name, year, everything has repeated, and it is happening for all the employees. We can see it is repeated for John, Josh, then we have Michael. So since we know that on 31st January 2018, it is part of January month, it is first quarter of 2018, and the day is Wednesday, and the year is 2018, then it is not making sense to repeat this information for all the employees. So we need to divide this data, or we need to distribute this data among multiple tables. Also, we can see there are a couple of more issues with this data. For example, let's say for employee John, who have employee ID 1001. Now we want to update the employee name due to some reason. Now here, when we apply the employee name update on this data, in that case, we need to update all the records wherever the employee ID is 1001. In that case, if you see, we have 1, 2, 3, 4 records and all the way down there. So to make a change for one employee, we have to update more than 4 records. And that is not a technically right thing because it will affect performance issue because it has to update 4 records instead of 1 record only. So we need to organize this data in a way that whenever we want to update anything, it should be minimum update. So the database performance should be improved. And the other issue we can see, also the other issue in this data, we can see that lot of information is presented in one table itself. For example, we have employee with department information. Then we have lot of date related or period related information like salary date, month, quarter. Then we have salary information as well. So there are different kind of 3 to 4 informations are available in one table. That is also not a correct thing. So now let's try to organize this data in a way that it should normalize data. That is required to improve database performance, and data can be referred with the required context only. So for that, let me scroll to the left. And here we can see we have one table date, then we have another table employee. After that we have one more table department expenses, and then we have table salaries. So for now, let's forget about the department expense and just focus on these 3 tables: date, employee, and salaries. So here you can see under date we have date key, then we have date, that is a date data type. Then we have weekday name, month name, quarter, year of this date, and month number. So here all the information related to date is stored within one table only. And then after that, under employee, we have all the employees related information such as employee ID, employee name, what is employee's designation, department ID, and then who is employee supervisor. Thereafter, in third table, we have salaries. Under salary, we can see we have just date key, that is the date. Then we have employee ID and then salary. So now here you can see all the information that we were looking here in this table. That was a denormalized data. Now it has been normalized on the left side tables between 3 tables. Now let's check the same issues what we were facing in a denormalized data, and let's try to apply here all that scenarios. So here you can see on the right side denormalized data, all the date related information such as date, then day of the date or month of the date, then quarter or the year of the date, all were repeating for the same date in denormalized data. But here we can see for one date we have one record only, and for that date all the information is stored in one record itself. So now we don't have any repeated date in this table. Similarly, in the next table we can see we have employees table. In employees table, we have employee ID that you can see it is not repeated. Then for each employee ID we have employee name. Then after that we have designation, department and supervisor of the employee. Here also you see we are not having any repeated information for the employee. So let's say if I want to talk about Michael, then for Michael has only one record, it is not repeated. Now let's say the way we were thinking to update the employee name for particular employee ID. So let's say for Michael we want to change the name here. So we need to update only this one record instead of the other way that we were seeing in the denormalized data where we have to update more than 4 records for one change. So this is data, you can see it is stored in a very structured way and it's not repeated data. This is called a normalized data. So in this data you can see since this data is not repeated and in this table we can see employee ID is the unique ID for this table. So this ID is the represent the complete record of this table. Then we can mark this particular employee ID field as a primary key for this employees table. Similarly, if I go back to date table, there we have date key that is a unique within this table. So we can mark this date key as the primary key for this date table. Now let's go to the third table that is salaries where we have date key, employee ID and salary. So now here you can see we have date key that is something coming from date table. So these two fields are somewhere related. So we can mark this date key as the foreign key to the primary key within the date table. So using this, we can join these two tables or we can refer salaries towards the date and we can pull all the date related information from the date table to the salary table. So let's see if I want to see what was the day on 31st January 2018, then I don't need to repeat that information from for all the 31st January 2018 salaries table. Instead that I will call this information from date table that is here we can see 31st December 2018 sorry 31st January 2018 and we can pull all the information from date table over here. The same way all the way wherever there is a 31st January we can just call this information from the date table instead of storing in the salary table. So here we can see now this data is really compact. It is not repeated. We can call it as atomic data, which can be easily stored, and it is really organized data where if we want to see only the dates, then we can just go with the date table. If we want to look for only employee related information, then we can go to the employees table. And if we want the employee salaries related information, then we can go to the salaries. And if you want to see combined information between salaries and let's say the employees, then we can simply join the salaries table based on the given field key that is let's say employee ID towards the employee table primary key. So far I hope you can understand what is the significance of keys in the table, what are the various normalization steps that we can apply on the data to organize data in multiple tables, and how we can store the data in a way that has performance and easy maintenance. Now let's go to the database and we will try to understand all this data and we will apply all the joins on these tables. Now we are in SQL Server Management Studio and here under Object Explorer you can see we have all the four tables that we see in a spreadsheet, that is dates, department expenses, then employees and salaries. So for now, let's focus on dates, employees, and salaries table only. So let's see what data we have under these tables. So let me query data from all these three tables. So here we have dates, then we have data from employees, and then we have data from salaries. And let's execute these queries. And here we can see we have same data what we see in spreadsheet. Under dates we have date key, then we have respect to date, weekday name, month name, quarter, year, weekday, and under employee table we have employee ID, then employee name, designation, department ID, and supervisor. And then we have date key, employee ID, and salary for the employees in salaries table. Now since we have data distributed in a normalized way between multiple tables, so now to make this data readable for consumption purpose, that we might require to join the multiple tables based on requirement. So now let's go through all the various join types available and apply that joins on these tables. To use the join, first we need to understand what is the order of the tables that needs to be followed. So say for example here, let's say we want to see employee salary for every month with employee name. So for that we need salaries that is going to come from salaries table. Then we have employee name that is going to come from employee table. So in this case we can simply first retrieve the data from first table, that is salary. So in our table order for the join, we can see we have salary tables at the first order. So here we can see we have date key, employee ID, and salary for each month. Now along with this we need employee information. So here we need to join employee table with salary table. But how to join that? For that, let's go to the presentation, and here you can see these are the various types of joins available. So let's discuss each join first, then we will decide which join we need to choose for our requirement. So the first join is left join, and in the diagram you can see for the left join we are getting all the data from the left table, then all the data that matched within the second table, that is also available, but the data which is not matched from the second table to the first table, that is not there. So you can see that is not colored over here, so that means we will not get that data. Similarly, if we go to the next join, that is right join, where we will get data from the right table and we will get matched data from the left table. So we are not getting to data from the left table which is not matched with the right table. So for easy to understand, we can easily remember this based on their names. So in left join, we get all the data from left table and only matched data from the right table. Same way for right join, we will get all the data from right table and only the matched data from the left table. Then the next is the full join, where we will get all the data from both the table, where we will have all the data from left table which is not matched with the right table, then all the data from right table which is not matched with the left table. Then we will get all the data which is matched between left and right table. So in short, if we get all the data from both the tables, then full join is the useful. Then we have inner join where we will have only the matched data between left and right table. We will not get data for both the tables which is not matched. So you can see only the inner circle is colored. So that is going to be result set for us. After that we have left anti-join. This is the data where we have data only from the left table which is not matched with the right table. We are not going to get any matched data from the left to the right table or even any unmatched data from the right tables. Same way for right anti, we will get only the data from right table which is not matched with the left table. So as we see, these are the various types of joins. Now let's apply this on the data what we have in SQL Server. So here we have salaries table, and along with salary we need employee information. So for that we have to decide which join we have to apply. So in salary we have employee ID, so that is something common field with the salaries and the employee table. So for that let's write the table name employee for now. Let me copy it from here. And we have the common field is employee ID. So let me give some alias for both the tables over here. And the common keys are employee ID. Let me verify from this. Yep. And then we have common key from salary table, that is employee ID. So now we have both the tables, salaries and employees. Now we have to decide what kind of joins we have to apply. So here, as we know, salary is the left table, and from the right table we need employee name designation. So we can apply left join over here because we need all the data from salary table with the data which is available from the employee table. So let's execute this command and see the output. And here you can see we have date key, employee ID, then we have employee salary, and after that we have employee name, designation, department ID, all the information from employee table. Now in this result set we can see we have all the employee information for what we have in salary table, but also we can see in record 1 where we have employee ID, that is 5000, but their respective employee ID, name, designation, or all the information that is supposed to come from employee table is not there. That is because this information is not available in employee tables. So let's verify this in different window, and here let's execute this. And here we can see we have employee ID from 1000 till 1005, and since 5000 employee is not here, so we can see for that the employee information is not available. But whatever the information is available for employee ID 5000 in salaries table, that is there in the result sets. So this is the perfect case that we can see for the left join where we have all the data from the left table and the matched data from the right table, but we don't have unmatched data from the right table. Now let's try to apply the right join on the same query where we need to get data from the right table. So all the records from right table should be there and the matched record from the left table. So for that In this query, let me change the left to the right join, and let's execute, or before execute this command, just look at the first record. So here you can see on the left side for employee ID 5000, we have data from the left table, and all the data from right table is the blank. And for the all the rest of the records, we are getting data from both the tables. So that means this is matched data. Only the first record is there, which is where we have some unmatched data which exists in left table but not available in the right table. So now let's execute the right join query on the same data and see the result set. And here you can see, if I scroll down last record, we can see we are getting data from the right table, but we are not having data from the left table. So here what SQL has tried to do, it pulled all the data from the right table, that is employee table, and joined it with the salary table, and wherever salary found for the employees, it tried to present it. So left and right are the just the opposite, that shift the priority from left to the right table and present data from the right table. Now let's discuss about the full join. In full join, as we know, we are supposed to get all the data from left table as well as the right table, whether it is matched or unmatched. We should have all the data. Here, so far what we seen, when we apply right join, we are getting 28 records. And let me go back to the left join and let's execute once again this query. And again we are getting 28 records. So in total in salary table, let's see how many records we have. We have 28 records. So there are 28 records in salary table, and with the left or the right join we are getting 28 records. That means there is a one record extra that is unmatched between salary and the employee table. And as per the our understanding from this diagram, we should have all the 28 records from the left table, that is salary, with all the matched record from the right table, that is all the table record from employee table, along with the unmatched record, that is the one record, that is employee number 5000. So in that case, in total we should have 29 records. So let's come back to the SQL. Now let's try to execute the full join. So for that I just need to change the left join to the full join, and let me execute this query. And this time you can see we have all the 29 records, where we have the employee ID with employee ID name, all the information from employee table blank. And if I scroll down to the last, and there I can see the record from the right table, that is employee, but where the salary information is not available. So in that case we can see the complete result in the full join. Now let's discuss the next join, that is left anti-join. So for left anti-join, this is a conceptual join. There is no keyword available in databases, or maybe in some latest database you might get this keyword, but as per ANSI standards, there are no such keywords reserved in the databases for anti-joins. But to achieve that, first we have to understand what is the anti-left join. So in anti-join, you can see we are getting only the data from the left table which is not matched with the right table. So all the data which is unmatched from the right table we will get from left, anti. Similarly, if I go to the right anti-join, there I will get all the unmatched data from the right table. So here we can see we can achieve these joins with some additional filter on the other available join types itself. So for that, let's go back to SQL and let me execute left join again. And here we have left join result set. And in this left join, we can see from record number 2 till the record number 28, all the records are matched as between the salaries and the employees. As we can see, there is a salary information as well as the employee information available. There is a only first record where salary information is available, but the employee information is missing. So this is the record which is unmatched between salaries to the employee. So we are expecting only this record as the result set from anti-left join. So for that, we just need to add an extra where condition here, where we can add where employee dot employee ID is null. And here we are getting only the unmatched record for the salaries table, which is not available in the employee table. Similarly, if we want to apply a right anti-join, for that it is very straightforward. First we have to apply right join. Let's execute only right join condition. And here we should have some record where on the left table we should have null that we can see 28th record. And here we can just simply apply salary dot employee ID is null. And we should get only one record that exists in right table, that is employee, but not available in the salaries table. So far we have seen all the various types of joins, that is left join, right join, full join and inner join, and some conceptual join which are left anti and right anti. Let me discuss the another join type, that is self join. That is again a conceptual join that where we don't have any reserved keyword from in the databases, but it is useful. So for that, let me remove this SQL query and let's focus on employee table only. And here we can see we have employee ID, employee name, designation, department ID. Then we have supervisor where we have employee ID of the employee. So let's say for row number third where we have employee Mike, and Mike has employee ID 1001 as the supervisor. So if I go to employee ID 1001, that is John. So that means John is the supervisor of the Mike. Similarly, if I go to the row number 5 where we have employee Josh, Josh has supervisor 1003, that is Ryan. So that means that Ryan is the supervisor of the Josh. In same way, Ryan is again supervisor of Eva as well. Now here you can see we have the reference field, that is supervisor, which hold the key to this other field within the same table. So when we are having the relationship towards the field within the same table, then whatever join we want to apply, whether it is left, right, it will go to the same table. That is called self join. So in that case, let's say I want to see the employee along with their supervisor name next to them instead of supervisor ID or along with the supervisor ID. For that, I need to apply some join. So here we have this table, that is employee, that will be on the left side as per the order of the information what we are looking for. So that is left join. And let me add some alias for employee table. And we want to left join to the same table, but this time this would be supervisor on, and from employee table we need supervisor, and from the supervisor table we need employee ID. And here, along with employee table, from the supervisor table we need name of the supervisor as supervisor. Now let me execute this query. And here you can see for Mike we have supervisor John. Similarly for Josh we have supervisor as Ryan, and same for Eva we have supervisor Ryan. And also for the records where we don't have any supervisor such as Ryan. Ryan is a supervisor himself. We don't have any supervisor. Then there we can see we have null. So that means supervisors for Ryan are missing. So now here we can see though we have applied the left join, but the table is trying to establish a relationship with itself only. This is called the self join. So in self join we can apply maybe left join, right join, or inner join, or whatever we can apply. But this will called as the self join since they are referring towards itself. Now let's discuss the inner join where we should get only the matched data from both the tables. So it should ignore the unmatched data from left as well as the right table, and it should return only the matched data between these two tables. So for that, here let me remove this query and apply select star from salaries, and let me add inner join this time, and let me add the employee table where we have employee, and let's join based on the salary employee ID is equals to employee ID. And from left and right join, we have seen so far we are getting 28 records, and in both cases there is a one record that is unmatched record from between those two tables. So in this case when we are applying inner join, so it should return only the 27 matched record from both the tables, and it should not return the 28th record which is unmatched between the left and right table, that is salaries and employees. So let me execute this query, and here we can see we have 27 records, and either side of the table, since join is based on the employee ID, so I shall not get null between both the employee ID fields. So let's scroll down and you can see we are getting employee ID for all the records for both the tables. So this is the inner join, and as a quick tip or as a best practice, we always try to give a priority to the inner join because it improves the query performance. So if possible, wherever in business requirement, if we can implement inner join, then try to implement this first and then only think of the other joins. Now let's move on and let's go back to our data which we have in denormalized format, and let's try to achieve this data from the all the normalized table what we have in SQL Server, and with some left or right joins we will try to achieve this result set. So let me keep this both the window open here, So we can refer the fields, and let's try to write a query from these tables, and we will try to achieve this denormalized data which we have in a spreadsheet. So first we have employee ID. So what we can do, we can pull it from employee salary table. Then we have employee name that we can pull from employee table. Then we have department. So let me, okay, before that, let me give this as employee name alias. Then we have department that is again available in employee table. Then next to this we have designation that is again part of employee table. Then we have supervisor. So we seen we can pull supervisor by self join. So since it is not here added, so let me add that self join again. So for that we have to left join the employee table. Let me give this as a alias as supervisor on supervisor.employee id is equals to, from employee table we have to pull supervisor. So now here for supervisor we have to pull from supervisor dot name, that is supervisor name. Thereafter we have salary date. So that is something will come from date table, because in salary table we have date key. So we need to join date table with salary table. So for that salary date key is equals to date key. And here now we can pull all the fields from date table, that is date dot date. Thereafter in spreadsheet we can see after salary date we need month name. So that also we can pull from date table. Then we need quarter. So here is the quarter. Then we have weekday name. Here is the weekday name. Then we have year, that is also available. Then salary, that should come from salary table itself. And that's it. Now let's execute this query. And here we are getting all the same output what from where we started. So this is the denormalized data what we see in Excel, but now we are pulling the same data from normalized data, where data is organized or distributed among multiple tables, which will return good performance and accuracy. Now let's discuss the union. So from diagram you can see union is something that we want to combine the data. But here the difference is, in the left join or right join, we usually combine the data from left to the right, or we can say horizontally. But in union, we want to combine the data vertically, where we will have table A and table B, and we want to combine it. So in that case, let's say if table A has 100 rows and table B has 100 rows, and where we combine it, we should get 200 records. So this is called the union. Under union, we have two different types of union. One is simple union, then we have union all. So in a union, we can combine data vertically. But what it will do, it will return only single instance of the matched record. So let's say in table A we have 100 records and table B we have 100 records. But 10 records are common, or we can say matched between these two tables. In that case, we will get 90 records from first table, 90 records from second table, and 10 matched record from both the tables. So this would be 90 plus 90, 180 plus 10 matched record, that is 190 as a result set. So the 10 duplicate record will not present in the union. But if we don't want to check for the matched record and we just want to populate all the records, whether it is matched or not matched, in that case we can use the union all, where if we try to union all table A and table B, there we will get 200 records. So let's see this on the same data set. So here in Excel, let's discuss the department expenses table here. Here in department expense, we can see we have date key, then we have department, and then we have amount. From here we can see on particular date for particular department, that is finance, there was an expense 2000. Similarly, on 28th February 2018 for finance there was expense 3000, and on the salary table also we can see on 31st Jan 2018 there was a salary 5000. So now let's say if we want to combine these two tables and just want to see what are the total expense, that is actual expense plus salary for particular date. So in that case, we can join these two tables. So let me first try to represent this in this Excel itself, then we will jump into the database. So here on date 31st January 2018, there was an expense 2000, and same way on date 31st January 2018, salary was 5000. So the total expenses is 7000. If we want to get this kind of output, that is you can see vertically combining the data, for that we can use union or union all. So let's jump into the database and let's try to achieve this requirement. Let me clear this query and let's write the query for the union. For that I need date and the salary from the salaries table, and we want to combine it with expense table where we have date key and amount from expense table. Let's for now just execute these two commands, and here we can see now we are getting two result sets. Instead of that we want only one result set. For that we can just simply apply union. So let's execute this command, and here we can see we are getting 40 records. So let's go back to our Excel, and here we can see for salary table we have 28 records, and for expense table we have 13 records. So let's see here, we are getting total 40 records. So in salary table let's check how many records we have. In salaries we have 28, and under expense table we have 13. So total we are getting 41 records, and when we do union, so we are getting 40 record. That means there is a one record that is exact match between these two tables. So here now instead of union, let me apply union all, And now let's see. Now here you can see we are getting 41 records. That means the matched record we are getting twice in this result set. So let me apply the order by to identify that matched record. And let's just quickly scroll through the result set to look for that matched record. And over here we can see on 28 February 2018, 3000 is the salary, and same way 28th February 3000 is the expense. So let's verify this in the spreadsheet. So on 28th February we can see there was 3000 expense, and similarly on 28th February we can see there was a 3000 salary. So here we can see when we apply union all we are getting 41 records, and if we remove the all then we will get 40 records, and the duplicate record will present once only. So far we discussed various types of joins and unions available in the databases, and we also discussed some basic examples how to join multiple tables and what are the various types of requirement to combine these tables that we can achieve using these joins and union. I would suggest to try to practice this and just go through this video once again and practice all the joins along with the video. And for practice purpose, if you need the data that you can download from Global Take Learn Telegram channel. Now let's see some complex requirement or some complex joins that we can achieve from this data. So let's discuss the first scenario where let's say there is a requirement where the requirement is along with the employee record. We want to see the latest month salary of the employee. So for there we need, let's say, employee ID. Let's say that is 1000 and 1001 along with employee name. And then we need employees latest month salary. So let's say here for 1000 employee, this is going to out of this. So this is the latest salary for Michael. And what is the date for this month? So this is the latest date. So this is the last salary that Michael has received and when he has received that salary. Same way for John. So here John, we can see John has received 3000 on 30th June. So let me copy it over here, and here is his salary. So in this way we want all the employees along with their name, salary, and the latest date when they have received latest salary. So to achieve this requirement, this is not straightforward that we can achieve with left or right choice what we have seen so far, because here we have to apply some filter on the salary table to get only the latest month salary. So for that, let's jump into the SQL Server again. Let me remove this query. And for that, we need employee table. So let me execute this query. And here we have all the employees. And so this is our left table. Now on the right side, we need each employee's latest month salary with the date. So for that, let me write another query. Select star from salaries, and here are the salaries. So now as since we need only the employee ID, then we need max date key. So let me add that, and then we need salary, and next we need group by, the employee ID. If you don't know how to use group by, then I have already covered group by in past video that I will provide the link in your description window, and I would suggest to go through that. For now, let's focus on this query. So here you can see we have maximum date for each employee. And now let's join this table with salary table again. Using inner join, and this time we will provide, let's say, salary alias to the salary, and to the next query we will make this as a subquery, and we will put this, and we will give the alias as the max salary or max date. Now we want to join these two tables on the max date dot employee id is equals to salary dot employee id and max date dot date key. Let me add that as max dt is equals to sal dot date key. Here we can see we are getting all the employee with their latest date, that is 30th June, and one ID has 31st January, and with their salary what they have received in their last month. Now in this whole query we want to join along with the employee. So for that, let me first put this query as a subquery, and then we can simply left join this table, and let me this give the subquery alias as max details or max salary on max salary, and join this on max salary dot where we have employee id is equals to this employee with employee id, and that's it. Now here we have employee information and all the information from the max salary, and let's try to execute this query. Oops, it says employee id we have multiple times, so let me give the details from max salary. So from max salary we are getting names from the max query. So here there we have max salary dot latest date, that we can call it as a max date. Then we need max date max salary dot salary, and that's it. I think this should work fine. Yeah, since we have added the sum, then we need to apply the group by. So let me add that group by department, and that's it. Yeah, here we can see we have total expense for the each department like corporate, finance and marketing, and next to this we are getting all the expenses that include salary as well as the direct expenses. So in this way you can see we have some long queries that might require some practice for you, that you can try again. I would suggest you to watch this video once again and practice it along with the video using the data. If you have any query or if you need any further information, you can put your question in comments window and I will try to provide you information. This is all for today's video. See you in next video with new topics. Till then, take care.